Hey there, welcome to another deep dive. Today's topic is building a data warehouse from scraped data, and honestly, this is one that I've been really excited to cover. There's so much to unpack here, so let's jump right in. As your web scraping operations grow, you quickly outgrow simple CSV files and basic databases. A data warehouse provides the infrastructure to store, organize, and analyze large volumes of scraped data efficiently. This guide covers the architecture, tools, and best practices for building a warehouse specifically optimized for scraped data. Let's start with why you need a data warehouse for scraped data. Scraped data has unique characteristics that make traditional databases insufficient at scale. The data is semi-structured and comes in varying formats from different sources. Volume grows quickly since even moderate scraping operations generate millions of records. Historical tracking matters because you need to compare prices, availability, or content over time. And query patterns are analytical in nature, meaning you're running aggregations and comparisons, not just looking up individual records. A data warehouse is designed for exactly these patterns. It handles large volume analytical queries efficiently. It stores historical data cost effectively. It supports complex aggregations across multiple dimensions. And it integrates data from multiple scraping sources into a unified view. Now let's talk about the architecture. A typical scraping data warehouse follows the ELT pattern, which stands for extract, load, transform. First, you extract data through your scraping operations. Then you load the raw data into the warehouse. Finally, you transform it within the warehouse using SQL or other tools. For the warehouse platform, several options work well for scraped data. BigQuery from Google Cloud is excellent for large datasets with its pay-per-query pricing model. Snowflake offers strong performance with automatic scaling. Postgres works well for smaller operations and is free. And ClickHouse is great for time series data and fast aggregations. For the data model, you want to design around your analysis needs. A common approach uses a star schema with fact tables containing your scraped data points like prices, listings, or content, and dimension tables containing the context like product categories, geographic regions, or time periods. For the ingestion pipeline, you need to handle several concerns. Deduplication ensures you don't store the same data twice. Schema evolution handles changes when source websites modify their structure. Data quality checks validate that scraped data meets expected formats and ranges. And incremental loading only processes new data since the last run. Some best practices for scraped data warehouses. Partition your data by date since most scraping queries filter by time range. Store raw data alongside clean data so you can reprocess if needed. Implement data lineage tracking so you know which scraper and proxy produced each record. Set up monitoring for data freshness to catch scraping failures quickly. And use compression since scraped text data compresses extremely well. Now for some frequently asked questions. What size of scraping operation needs a data warehouse? Once you're storing more than 10 million records or querying across multiple scraping sources, a data warehouse becomes valuable. For smaller operations, Postgres with good indexing is usually sufficient. How much does a scraping data warehouse cost? Cloud warehouses like BigQuery cost based on data stored and queries run. A typical scraping operation storing 100 gigabytes of data and running daily analytical queries might cost $50 to $200 per month. Self-hosted options like Postgres or ClickHouse only cost server resources. Should I store raw HTML in the warehouse? Store raw HTML in cheap object storage like S3, not in the warehouse. Keep only extracted, structured data in the warehouse. Link back to the raw HTML with the URL or object key if you need to reprocess. How do I handle schema changes from scraped websites? Design your ingestion to be schema tolerant. Store unexpected fields in a JSON column. Use staging tables to validate data before loading into production tables. And set up alerts for schema drift so you can update your scrapers promptly. That brings us to the end of today's guide on building a data warehouse from scraped data. I packed a lot into this one, so if you need to, feel free to come back and listen to certain sections again. And if you want even more resources, dataresearchtools.com has hundreds of articles on proxies, scraping, automation, and more. Thanks for tuning in, and I'll talk to you soon.